right, let's take a look at some examples of graphing exponential functions for section 9.3. The first one I'd like to do is f of x is equal to 3 to the x minus 2. Now we're going to use the same techniques that we used in chapter 3 to graph these functions. In other words, we're going to pay attention to what transformations are happening. So take a look at this minus 2. What effect is that going to have on the graph? Well, remember that shifts it down 2 units. So I'm going to start by sketching in my basic function here. And again, my basic function for the exponential function here is 3 to the x. So I know that the basic shape it takes on is this shape right here. Again, it has a key point of 0, 1, and it has an arc that goes through it that doesn't cross the x-axis. Now, I'm going to start with a key point and I'm going to shift it down 2 units. So it's going to end up here at 0, negative 1. So your key point is at 0, negative 1. Now, if the key point has shifted down, you also have to pay attention to what's happening to the asymptote. The whole graph is shifting down, so therefore the asymptote shifts down as well. And it's going to shift down 2 units, and it will end up being at y equals negative 2. Now remember, the asymptote is not actually a part of the graph, so we dot that in and we use that to guide our graph. And so here is the sketch of the graph. So again, first thing I look at is my key point. I decide where that's going to end up. The second thing I look at is my asymptote. Once I know where those 2 things are, then it's just a sketch to get the rest of the graph onto the graph. All right, let's take a look at another example. This one can sometimes be a little bit tricky. The second one I want to look at is f of x is equal to the opposite of 2 to the x. Now, be very careful here to pay attention to the fact that this is not a negative 2. Remember that our base for exponential functions cannot be negative. So when you evaluate this expression, you do 2 to the x and then you take the opposite of that. Now that little negative sign has an impact on the graph that you might recall. It's actually going to reflect the graph. Now how does it reflect it? Well, think about whether it's impacting the x's or the y's. In this case, it's impacting the y's. So it's actually going to be a reflection across the x-axis. So again, I'm going to start out with a simple sketch of my basic exponential function. So I dot it in. Again, it goes to the point 0, 1. Pay attention to that. And then I'm going to take into account this reflection. And it's a reflection across the x-axis. So that means the key point is going to come across the x-axis, and it's going to end up here at 0, negative 1 once again. So again, there's my key point. Now let's turn our attention to the asymptote. Now the asymptote was the x-axis, or y equals 0. So if it's a reflection across the x-axis, you can't really reflect the asymptote, so therefore the asymptote is going to stay right here at y equals 0. Now I need to remember that the shape is actually reflecting across here, so when I go to sketch in my graph, it's going to come down and it's actually going to decrease from left to right. Again, I'm not going to touch my x-axis with the graph because I want to make it very clear that it never touches or crosses the asymptote. So there would be the sketch of that particular graph. All right, let's take a look at one more. Suppose, for example, I have h of x is equal to 3 plus 2 to the x plus 1. Now this one's a little more complicated than the previous two, but let's again focus on what's happening here. Now my basic function here is my 2 to the x. So what else is happening with that 2 to the x? Well, notice we have this plus 1 up here. That's with the x, so therefore it's going to be a shift left 1 unit. Okay, the other thing we have is this 3. Well, this is a positive 3, so it's going to shift up 3 units. Now the plus in here tells me there's not going to be any reflections, so I can go ahead and sketch my graph. So let's see, my basic shape is right here. It has a y-intercept and key point of 0, 1, but now we're going to pay attention to where is that point going to end up. Well, it's going to move left 1, so I move left 1, and it's going to move up 3. So I go left 1, up 3, and my new key point is going to be right here at -1, 4. So I locate that key point again to start with. Now I have to think about, well, what happens to my original asymptote? Well, the asymptote is only going to be impacted if the graph moves up or down. Left or right does not impact the asymptote. So it has a shift here of up 3 units, so that means my asymptote is going to move up 3 units. And so I sketch in my asymptote at y equals 3. And the shape is going to stay the same like this because there's no reflections, and so I can sketch in my graph here, and there is my final graph for that. Now, notice that the asymptote value and the shift up tend to be the same, and that will always be true because, again, the vertical changes to the graph are what's going to impact the asymptote. Notice also that the shift to the left or right impacts the x-coordinate of the key point. So those are things that you can kind of pay attention to and utilize as you're graphing these functions. So just as a recap, remember to first figure out where that key point is going to be. Second, figure out and sketch in the asymptote, again with a dotted line because it's not part of the graph. And then the final thing is just sketch in the graph. We're not going to worry about how steep the graph goes at this point in time, but make sure that it does not touch or cross your asymptote. Please see the website for the assignment for this section.